If you are watching this video, chances are you missed our lab day in class. So as you guys can see right here, I have a small 50 milliliter beaker that is filled with salt, sand, and iron all mixed together. What we're going to be doing is figuring out a way to separate this. Before we get started, I would like you to answer the first 6 pre-lab questions on your worksheet. For number 3, the mixture is asking, what kind of mixture is this? Take a look at what this looks like. This is a mixture of salt, sand, and iron. It's more asking, is it a homogeneous mixture or a heterogeneous mixture? When you are finished with that, check back here to see what the results were for our initial calculations. If you're watching this, then you've answered the first 6 pre-lab questions, and we are on part 2, creating the mixture. So we made this mixture in class together. So our results were 54.1 grams. For the cup, the salt was 5.1 grams, sand was 2.9 grams, iron was 5.3 grams, and the mass of the sample, which was the salt, sand, and iron added together, was 13.3 grams. If I scroll down a little bit here, you'll see we also calculated the percent composition. So this is how much of the mixture itself was made of each of these items. So to find that, we did the mass of the item divided by the mass of the sample times 100 in general. And that gave us the percent of the sand for that one. Our results for that were the sand was 21.8% of the mixture, the salt was 38.3% of the mixture, and the iron was 39.8% of the mixture. So now we have our mixture here, and we have decided that the first thing that we should do is to take out the iron because it could rust if we put water in with it. So I've got my magnet here. I'm going to take it. I'm going to put it directly into my mixture. And as you can see, it pulls out a lot of that iron. And I'm just going to put that back in, and I'm going to run it through a couple times here. Take a moment and write that down as in part 3 of your lab here. The next step that we discussed was adding some water to our mixture because the salt will dissolve, but the sand will not. So here we go. There we go, and I'm just going to stir this up a little bit using my stirring stick, which we like to call a chopstick here. What should we do now that we have that stirred? Please make sure that you write that on part 3 of your lab. Our next step that we decided to do with our salt water mixed up together with our sand, we put a filter in our funnel here, and we put that into a 100 milliliter beaker. I am just going to take my mixture here, and I'm going to pour it into our funnel.
What is that thing called, that tube thing that you put the salt water in?
The funnel. And for our next step, we have a pan on a stovetop. I'm going to turn that stovetop over to high, and we're going to boil our salt water to hopefully get some salt back. So here I go. I'm going to add this in to our pan, and we're going to see what happens. As you guys can see, this is what it looks like when it first starts boiling here. It's first starting to get hot. As you can see, this has started to really boil, and the water is really starting to evaporate here. You can see that as it boils, different pockets of salt are left over from where the water has boiled away. So that has kind of helped us get back our salt. This is just a quick look of what our salt water looked like at the end of our section here. So now we reach our final results. We actually measured the mass of each of those different substances and containers that we use to measure them on a triple beam balance as a class. Our final results of the containers were: container 1 was 490.5 grams, container 2 was 437.5 grams, and container 3 was 28 grams. Over here, the mass of our ingredients that we had here, our substances, were 6.1 grams for salt, 3.7 grams for sand, and 4.8 grams of iron. After we did that, we calculated the percent recovery, or how much of the substance we got back. We did the total mass of the sample recovered, so that was the mass of these three items, divided by the mass from the beginning, which was 13.3. And what we found was that we got 110% back, which is a little weird because it was higher than what we started with. So you might need to think of some reasons why that is the case. Please take your time now, go through, and answer the questions that are down at the bottom. Question 1 asks, how did you separate the sand from the salt? Question 2 asks, how did you separate the iron from the mixture? And 3 was, how did you separate the salt from the water? Number 4 is asking if each of these substances are homogeneous or heterogeneous. And the bottom is talking about percent recovery. If your percent recovery is lower than 100, what are some situations where you might have gotten less than what you started with? And question B is, when might it have been greater than 100? When might you have had more than what you started with? Take your time, answer these questions, and if you have any questions, please make sure you ask me.